Hey guys, welcome back. Today we're going to look at a different tweeter. It's a ribbon tweeter from a company you don't hear much of. It's a Viawave, the Viawave GRT145. It's a little more of a higher end tweeter. It retails for about $250 US each. So it's a little higher up on that scale, and it's not for the budget builders. But it does have some, interesting capabilities that are worth noting that extra money gets you. I'm going to compare this tweeter to the Fountek NeoX 2.0. I have that tweeter as well in my possession. I'm going to measure them on the same day at the same time, and that video will come next. Moving forward, let's get on to testing this thing and see what it can do. The first thing I needed to do was make some test baffles for both the Fountek and the Viawave tweeter. I used my CNC to do this on a baffle that I figured was pretty standard and conventional for what most people would want to use this tweeter in. Given the fact that most people would mate these to a large format mid-range, by that I mean 4 or 5 inches, and then a woofer below that, I picked a baffle based on those kinds of principles. I finally got my CNC back up and running after some problems. This was actually the first thing I cut. Here we have the packaging sent to me by the supplier of these tweeters. They came from the United States, not in original packaging. I was a little unsure how they would come to me, but overall they made it here safely, but it's not indicative of the original packaging, at least as far as I know. Let's have a closer look at these beauties. And beauties they are. They truly are beefy, well-built, well-machined, clean, solid. Need I go on? I mean, they really are tremendous looking. They're simple in their style, a round faceplate. Rather, simple in design and not so flashy, but you can tell there is a lot of quality and thought that has gone into putting these together. Then I fastened the baffle to my terrible speaker stand for measuring. Here you can see the baffle is about 195 millimeters wide. The tweeter is 20 millimeters from the top and 350 millimeters total height. The more important dimensions is the 20 millimeters from the top and the 195 millimeters wide. I got everything hooked up and I used a 20 microfarad capacitor at first, and I'll discuss this more later, but I realized that was much too small of a capacitor. So although I used it for all the off-axis measurements and things like that, I did go back with a larger 50 microfarad capacitor to test the on-axis response. The 50 microfarad cap was actually used for these measurements right here. So this, right off the bat, this is the on-axis, and we can see we are getting extremely high sensitivity. Above about 4,000 kilohertz, we are seeing 101 dB, like an impressive 101 dB. It is a 4 ohm tweeter. We'll look at the impedance in a little bit, so keep that in mind. But the other thing to note here is that both tweeters measure very close to each other. We're seeing very little deviation between the two. So overall, I'm very pleased with the results we see here. These are the off-axis measurements horizontally, and you can see the 20 microfarad cap was used in this case, and you can see the roll-off below 3,000 kilohertz was a little bit different. But what we can get from these measurements is we have very smooth, very consistent, aside from some diffraction between 2 and 3,500 hertz, you're getting really consistent off-axis measurements, really smooth. This will be very pleasing to listen to at all angles in the room. Overall, a very good result here. Once I had measured the on-axis response and horizontal response, I flipped the baffle raised it a little higher, and started measuring the vertical response. Again, this is with the 20 microfarad capacitor, and here we can see that as most ribbons exhibit, the vertical behavior is a little more pronounced. You get a lot more directivity, but you know what? This is actually not bad for a ribbon. This is quite tolerable. Vertical directivity isn't necessarily a bad thing, but you can see here it really is, you get a little bit above 7,000 hertz, but mostly it's in the very top octave. This is quite a stellar result in my opinion. You may recall my test of the Fountek NeoX 2.0. It's a taller ribbon, and the vertical off-axis response was quite difficult to manage. Next up, I hooked it up to my impedance jig and got some impedance tests. So this is sample 1 and 2, just without any protective cap, just straight out of the box kind of thing. You can see that we have very good consistency between the two ribbons. And what we also see, which is really notable, is the impedance profile is super smooth and clean. No resonances except for, around 700-800 hertz kind of thing. But within the pass band and even well into the stop band, these things are incredibly smooth. They should be easy to work with. So overall, very good result here. Very consistent, very smooth. Very happy with this result. Okay, here is the measurement. I have the Fountek results shown here as well. So spoiler alert, you'll hear more about that tweeter in the next video. But if you look at the lower two graphs, the yellow and the turquoise kind of color, you can see the yellow is the unfiltered impedance plot of the Viawave, and the turquoise colored plot is with the 20 microfarad cap in place. So you can see that the 20 microfarad cap, although it protected the tweeter quite well, it also really influenced the response. And it was after I looked at the results and then took this test, I realized, you know what, that was too small of a cap, and I should have known that. So you can see the plots begin to diverge below about 4,500 hertz, and that is just too much of the useful bandwidth to influence. It also added a little bit of sensitivity to the region above 5,000 hertz. So I went back to my shop and set everything up again and remeasured these things because I didn't want to take any shortcuts. I could have just presented the information the way I had it, but I didn't think it was fair to both of these tweeters. So here we have the 50 microfarad capacitor protecting these tweeters, and you can see, sorry, the colors keep changing around, but blue is the unfiltered impedance plot of the Viawave, and yellow is with the 50 microfarad cap in place. And you can see it really doesn't affect anything until below 2,500 hertz, and doesn't affect anything significantly until below 2,000, even below 1,000 hertz. So this is a much more useful result, something that I'm comfortable giving you guys the file. It's available on Dropbox. You can download it and use the file to simulate a crossover if you like. So the last thing I do is I wanted to just see how workable this tweeter was. So I plop it into XSim here and just start chucking components at it. I always kind of start with a second order crossover, and if it's a tweeter, I put an L pad on there as well. So that's what I've done here, and just wanted to see what happens. As I mentioned earlier, there is that dip at about 33,000 hertz. I was able to work it out. This is a diffraction related dip, so you can't beat it out too much because as you move off axis, that diffraction dip will fill in. So it's okay to leave it in the response a little bit. No need to get too carried away with it. And when you look above 4,000 hertz, where a ribbon tweeter of this size really shines, this thing was rocking with just a few components. So there you have it, guys. That's the Viawave tweeter. Hang around. We're going to look at the Fountek NeoX 2.0 very soon here and check out what it has to offer. I do have available these ScanSpeak 15M mid woofers, mids. They're not mid woofers. They're dedicated mids. This mid-range will get you down to about 120, 150 hertz. Stick around for the Fountek. stick around for a possible design with this, and also stick around for the comparison between the Fountek and this Viawave tweeter. I think you will like it.